Our next talk is John Alexander. He's the Executive Director of the Klamath Bird Observatory. There is some really cool stuff going on right now in terms of some modeling at thresholds for how you could manage focus wildlife, particularly birds, on a landscape basis, particularly a watershed. And when I saw this stuff, I thought it was really, really cool, and it needed to get out there, and I hadn't seen it being out there very much. So we got John here to come talk about it, so help me welcome John while I pull up his talk. What's that?
I had opened it, so it's one of those windows.
Oh, you're just, which one? Good job. He should have been running this the whole day. He's got it all down. Okay, there you go.
Great. Well, thank you very much for this opportunity. What I'm going to talk about today is what some of the tools that can inform management planning that have emerged out of 20 years of Partners in Flight. Partners in Flight is an international bird conservation initiative with the mission to keep common birds common while reversing declines of at-risk species. And while the mission has always been bird-centric in that you might think we want to manage for birds, the science that's come out of Partners in Flight has actually allowed us to take a different approach to bird conservation and really ask, how can the science that we've developed through Partners in Flight help inform ecosystem management, help inform, more broadly the way we manage landscapes and we manage ecosystems to be more successful. And we believe, especially in the West and the way we've approached Partners in Flight, that if we can use the data that we've collected using very cost-effective monitoring techniques to inform management, that bird conservation will result from that. So as opposed to me coming to land managers and saying, I want you to manage for hermit warblers or this, that, and the other, we're more saying now we have some tools that we can use in landscape management planning to help meet the objectives that have been identified, especially in these kind of restoration contexts and whatnot. The Forest Service was incredibly influential in Partners in Flight, as was the BLM in investing in Partners in Flight. And so really it's an opportunity to take that investment and feed it back into the system. So one of the things I want to talk about is the data community that's evolved out of Partners in Flight and thinking about birds as indicators. Think broadly at a continental scale about assessments opportunities and how we can look for conservation opportunities, listening to what birds have to tell us. And then kind of drill down a little bit more regionally and even to the project level and talk about how management planning can be informed with the science that has emerged out of this program, add a climate context to that, and then provide some examples or an example of how this could be applied in a forest management planning scenario. So there's an organization called the Avian Knowledge Alliance, which is a group of NGOs and agency partners that are involved in collecting and caretaking information about birds and habitats and communicating what we learn about listening to birds, not just one species, but many species of land birds, songbirds across the landscapes. And we take advantage of the unique capacities of non-government organizations. And when I talk about non-government organizations, I'm talking about the Bird Observatory model to science delivery. These are mostly non-advocate organizations that focus on applied science. They're institutions that support observation-based science that use birds as indicators of ecological conditions, and as is being recognized more and more as of lately, that birds are also excellent indicators of our economic well-being and our social well-being. And then at the core of this partnership, this community of data ambassadors is the Avian Knowledge Network. And what we're trying to do is think about the social context. And over the last decade plus, we've spent a lot of times thinking about the decision makers and working with the decision makers through mixed methods of social science to understand what are the delivery points for this information that we have. And beyond making sure that our science is respected through the peer review process, what are the mechanisms for delivering these scientific results in the form of decision support tools and decision support systems that get at the challenges that land managers face. So really thinking about how can we bridge what's very well documented, the gap between academia and the way science is done and management and the way we make decisions on landscapes. So the Avian Knowledge Network is a sophisticated distributed data system that includes the user, the end user of the data, and then also the data providers. The data providers might be your next door neighbor or yourself who's an avid birder, or it could be the district biologists who go out and implement small bird surveys, or it could be some of these organizations that develop broader monitoring programs. And we have this distributed system that involves different nodes. Some of these nodes are thematic, migration monitoring. Some of them might be regional, the Avian Northwest, the Avian Knowledge Northwest. And some of them might be agency specific. We've been talking about developing a node potentially with the Fish and Wildlife Services INM inventory and monitoring program. So different nodes that bring data together into a consistent format so those data can be delivered and then used to develop different decision support tools. So in the process of working through Partners in Flight and the Land Management Agency's investment in Partners in Flight over the last 20 years, we've really been thinking about this adaptive management model. And how can we use birds and the information we collect about birds and their habitats to assess conservation needs, set measurable objectives, help design the management, and then measure the effectiveness. And there's a series of tools, both national in scale and local in scale, that have been developed, including species assessment databases. So when we're thinking about NEPA and we're thinking about the priority species or sensitive species, we have the best available science that assesses all the species in North America. And that goes into what's called the Birds of Conservation Concern, which is one-stop shopping for getting the best available science as far as birds are concerned, for understanding what our birds of conservation concerns are. We have a series of conservation plans that consider not only birds of conservation concern, but also more abundant birds that make excellent indicators that you can actually monitor across the landscape and understand what they tell you about landscape change. And then a conservation design process that's based on waterfowl conservation, which is one of the globe's most successful conservation movements on record. So I asked a question earlier, why is it that adaptive management isn't being implemented to its fullest? And one of the reasons I think it's not is because we spend a lot of money designing, implementing, and even monitoring. And as bird observatories, we've done an excellent job. Land managers come to us often and say, we're going to do this project, will you come and monitor the effects of it? And of course we will. But what we really want to do is make sure that this arsenal of data that we've created gets plugged into the evaluation and the adjustment and the assessment and the design. And that's what we're here really to talk to you about, is how can these tools and the stories that birds tell us take broad objectives and actually create quantifiable habitat objectives and quantifiable population objectives that can be scaled so we can actually, in a cost-effective way, evaluate the alternatives that we put forth for meeting certain objectives across landscapes. I'm keeping my eye on the clock. And so what we can do is we can assess stewardship responsibility continentally. And then when we get to the planning process, whether it be forest planning or groups of forests or Western Oregon plan revisions, we can look at the broad objectives that are put forth in resource management plans and, considering those at multiple scales, set quantitative habitat and population objectives and then use those to compare alternatives through some of the modeling tools that we have to inform those alternatives. We could, if asked, create alternatives that are based on our conservation plans as well, but really what we want to do is use the information to evaluate the different alternatives that are being put out there using the different tools. And so then we can turn around and think about NEPA. So first of all, we're trying to think more broadly about what are objectives, but then create simple tools that can be used to make sure we're meeting our NEPA requirements as well from a birds of conservation concern. So I'm going to start with a continental assessment. This was developed by Cornell. eBird is a very broad global node of the avian knowledge network that takes advantage of the bird watching community. It is one of the fastest growing biological databases in the world. And so what we did was assess stewardship responsibility of public lands across the country. So for fun, we're going to take a quick ride on the back of a rufous hummingbird. Now, some people come and ask me, do rufous hummingbirds get on the back of geese? And is that the way they migrate? No, rufous hummingbirds actually migrate on their own, to the best of our knowledge. And so with all of this bird data that eBird has collected, we've created, and we being Cornell Laboratory of Ornithology, 365 day-a-year distribution models for the entire continent of the United States that we could use then to assess stewardship responsibility on public lands throughout the year. So here we are in January, and there's wintering birds down in the south of the United States, and then we know that there's a circular migration of rufous hummingbirds up into the northwest, where during May and June, they're restricted to their breeding grounds, where they spend the smallest portion of their life cycle. And then during fall migration, the adults, followed by the babies, work their way back down south through the Intermountain West, back towards their wintering grounds. And so we can use this information to think about these assessments on public lands. And from that, here's the breeding grounds, came the first evaluation of stewardship responsibility and what I think of as stewardship opportunities on public lands throughout the United States. And we can see western forests, as we all know, public agencies have a big responsibility, and therefore there's great opportunity to allow birds to guide the restoration of these lands. 55% of western forest birds occur during the breeding season on public lands, 34% of them on Forest Service lands. Those are western forest obligates. And then we can think about each different species and break that down to where are these birds on Forest Service lands. And this is a work that's happening through the Forest Service International programs and Cornell and Partners in Flight that takes a look at the gap analysis. So gap 1 and 2 are those protected lands, wilderness. And then gap 3 are these multiple use lands. And so there's a great opportunity to do conservation for this species or the whole suite of forest species in these different landscapes. And then we can think about beyond the breeding season. Yes, the Forest Service responsibility for rufous hummingbirds, and I just used rufous hummingbird as an example. We're really multi-species in our approach in thinking about bird communities. But what happens to rufous hummingbirds when they start heading down in the Intermountain West? They become dependent on riparian and high elevation areas on Bureau of Land Management needs. So collaborative opportunities for full life cycle conservation of these species. So continentally, we understand that the Forest Service and the BLM and others in the West have an excellent opportunity for doing bird conservation. And what we want to show is how what we've learned and how our bird conservation plans might inform these broader scale or broader issued restoration questions that we're asking. And so we consider a focal species approach. And I'm sure there'll be people in the room that'll shudder when I mention the Fish and Wildlife Service's new surrogate species program. Now, Partners in Flight has done a lot of commenting on the guidance of surrogate species, in that we want to see communities of birds or any other kind of animal at that can be inexpensively monitored using a single monitoring technique be considered as a surrogate. So we don't want to horse trade the brown creeper for the salamander. We want to consider forest birds as a surrogate for condition, and I'll show you examples of that. So focal species are not only at-risk species, but more abundant species that are indicators of suites of habitat characteristics that are important within functioning ecosystems. And so these focal species can be used, and there is guidance under the Migratory Bird Treaty Act and the Executive Order and the new Executive Order Council for managing memoranda of understandings between the agencies and the Fish and Wildlife Service that say, not only do we want want you to, document in NEPA concerns about the species of conservation concern, but let's use the Bird Conservation Initiative's tools to improve the way we do ecosystem management. So these focal species can be used in forest management plans and regional BLM plans to help set quantifiable objectives that can be used to compare alternatives. Getting involved in the scoping of these projects and in evaluating. And then we can turn around to the Birds of Conservation Concern list, and as we design projects within that broader restoration context, make sure that we're considering the species of conservation concern that we're required to consider on the landscape. So we have a series of bird conservation plans that have been written for the West, the entire West, from California, Oregon, and through Washington, the western United States, that take this focal species approach. The newest plan is a revision of the coniferous forest for west side of Oregon and Washington. And what these plans do is they consider the suite of species across the landscape and how that suite of species represent not only the successional stages that a lot of the conversations that we've been having all day long have been talking about, but the important habitat conditions that occur within those successional stages. If you build it, do they actually come? Not always. And we've learned this and published some interesting information in oak woodland restoration that some kind of restoration techniques are much more effective at meeting that ecological condition as represented by a suite of bird species than other restoration approaches. So these conservation plans consider the focal species and then the whole group of bird species that would fall in to these scenarios as you move an ecosystem from one place to another through restoration techniques and whatnot. And so each of these species have very specific habitat objectives. And this is where we get to what birds are on the landscapes, what are your general, objectives for restoration, and how can we use the information that we know about bird habitat relationships to quantify those objectives and get more prescriptive. So I don't necessarily want to read this, but just to understand for each of these species, there's a suite of very prescriptive habitat needs that we can put together and then frame within the quantifiable habitat objectives. And then we can ask, on the ground, what's going to happen to the bird species? In the watershed, how is that going to affect the populations? From a large planning area, how are we going to meet continental population objectives for these species based on, is the restoration we're doing relevant? And at what scales is such restoration relevant with regards to the birds as indicators of ecological conditions at various scales? So let's think about forests in the Pacific Northwest. In this area, we could think about as suitable habitat for spotted owls, let's say. Here's a bunch of more habitat in the Elk Creek watershed, for example, if I heard the presentation correctly, that's designated as critical, but it's not yet suitable. And so a lot of the restorations intended to move that habitat towards more suitable habitat for spotted owls. Well, what's concerning about that from an understanding whether we're meeting our ecological condition, the other day at the Wildlife Society, Jack Ward Thomas said that using the spotted owl as a surrogate for whether we're managing ecosystems for spotted owls effectively is like eating Jell-O with chopsticks. First of all, they're not in the habitats that we want to manage towards their suitability. And second of all, there's confounding factors whenever you think of single species management as to whether they're going to respond because of other pressures, including the barred owl. So how can we know that we're moving these habitats in this direction well? We are starting to demonstrate that you could use this suite of birds here to understand whether that condition is being reached on that landscape at various scales. We either, if a forest burns, the other issue that we've thought about, and we've got some literature from Oregon State University that talks about some of this with our collaborators, that habitats either have not been allowed to burn, or when they burned, we were conifer-centric in our management of those habitats. And so this whole successional stages from which coniferous forests naturally emerge have been managed against. And it's some of these species that are most at risk from a bird conservation perspective in the Pacific Northwest. So how can we fully consider this successional cycle in our restoration context, and how can we use these bird conservation plans to inform that across the landscape? So I mentioned an arsenal of data. We just finished a project with the North Pacific Landscape the North Pacific Landscape Conservation Cooperative, where we brought in 900,000 new bird observation records into the Avian Knowledge Network, building from the work that Point Reyes Bird Observatory and Klamath Bird Observatory had done in the south, and bringing in all of these data sets that were at risk of extinction because they were sitting on shelves or sitting in computers and not being used, into the Avian Knowledge Network, where you can go now and explore these data. And then, considering the recent State of the Birds report about how birds can inform climate-wise management, we wanted to do a project where we did some modeling of current distribution and future distribution to develop a set of tools that could be used in management planning. Identify, obtain, and federate data, compile GIS layers, model current and future bird distribution, and then use these models to identify conservation priority areas and create a tool where you can go to look at all of these different decision support systems, as they might be called. And so my slides are getting a little out of whack here, but that's okay. So we explored several source vegetation maps and decided to create a hybrid GIS gap layer that we thought would be relevant to managers with regards to management planning, but that would also be good for modeling bird distribution. And one of the things that was exciting is that we asked ourselves, based on the environmental space, how well have we monitored birds out there? And besides some of these very high elevation areas and some isolated areas of the coast, we've done a pretty good job at sampling the potential environments out there for birds in the Pacific Northwest. And so then we could develop, using current climate and future climate, these different scenarios of bird distribution and assess where there'll be the most amount of change, for example, based on the vegetation community and based on bird community turnover. And this was built on a paper that was published out of Point Reyes Bird Observatories and others in California, where we looked at these kind of data and asked about novel bird communities in the future. And then, from a conservation planning perspective, bring all of this information together, make sure that we're discounting areas where the climate models are very variable in the results that they produce, to create these maps of conservation priorities. How are these, if we consider different suites of species, based on the current and future distributions of these species, the darker brown areas are areas of high conservation priorities. So now, when you're thinking about all of these watersheds and using all these wonderful tools that we might be able to use to assess conservation or to assess treatment needs, we can use these kind of maps to assess where we might spend our limited dollars and prioritize treatments in areas where they're most likely going to be effective. So we might not want to do, if we have oak, we're using this a lot on private lands oak restoration. There's a lot of private lands oak restoration opportunities. How do we prioritize those sites? This might be a way to prioritize those sites. We want to make sure we're not managing for oak forest birds in areas where we might want to be managing for coniferous forest birds, especially in these areas where it's a mix of conifers and hardwoods. So the 5 elements process is something that's built on Baxter, which was what the North American Waterfowl Management Plan was built on, where we can take landscape assessment, use the population response models, and think about opportunities on landscapes. Where are our conservation opportunities based on ownership, based on feasibility, and develop, spatially explicit landscape designs for doing restoration and conservation using the information we get from birds to help guide that process. And then, if we really use the data that we've collected to help guide the management in the design and the assessment, maybe monitoring will no longer be thought of as an afterthought, but we'll be using the information that we collected in 20 years of monitoring investment to do the management, and the monitoring will just come. Great. I am almost done. So here's an example on the Klamath National Forest where we're using these models. The Klamath National Forest is going through and doing an assessment of restoration opportunities based on fuel load models and based on other kind of traditional tools to understand and prioritize the watersheds for restoration for various objectives. And then what we're going to do is turn around and overlay our bird distribution models to help then, at least inform the decision makers about the prescriptions that could be used based on the needs of the birds that might exist there currently or in the future. and then do a conservation opportunities assessment based on the ranking of their watersheds using this kind of data-rich information. And the Klamath National Forest is one of those forests where we just have already, covered over the last 20 years with data. So we've got a lot of data, but then the distribution models smooth those data out across the landscape. And then you can actually get down to the project level and look at the suite of species that are there and start to, once you've got a larger management plan on a forest, think about project level planning and the prescriptions that you might use in each project that fit within the preferred alternative within those larger land management planning. And use those conservation plans to guide the design of those projects, and then use the birds to measure the effectiveness of whether you're actually meeting the objectives. I'd like to thank a lot of different people, but a lot of the climate stuff I just showed, Point Reyes Bird Observatory, PRBO Conservation Science, took the lead on that project, the American Bird Conservancy, the North Pacific Landscape Conservation Cooperative, and of course the Forest Service and the BLM that have supported this bird monitoring over the last 20 years here in the Pacific Northwest. And there might be time for a question or two.
We have time for a question or two of John. The crowd is thinning.
They're leaving.
It's nothing personal, it's just that time. Question?
Near the beginning, you were talking about, I think you were talking about using the eBird data to generate where birds were using the landscape, comparing forest, public lands versus non-public lands. My understanding with eBird was that it was based on where users chose to go and report, so anybody could put in for any time. So how do you do the analysis of that, or maybe I'm wrong, when you have non-randomized points like that?
So can you repeat the question?
Yeah, the question is if birders go where they like to bird, and they might not, I mean, that's not, I'm just going to paraphrase and nod if I'm completely wrong, but where the birder, if birders aren't, randomly designing where they go and they're providing these data, then how can we use that information to develop, scientifically valid models across landscapes? The amount of data is swamping the system. And so there's so much of it out there. That's one of the ways they're dealing with this. And then they're using machine learning to create these, those continental models are built with hundreds and hundreds of regional models that lay on top of each other that account for data gaps and all of those other kind of things. They're called STEM models. And I think Cornell's published a couple papers about that. So they really are thinking about accounting for these kind of things, but it's an overwhelming amount of data that are being put into that. So just in the volume of data alone, but the modeling approach is very sophisticated, and they're using huge stacks of machines to generate these models. So they are accounting for those kind of things, and some of that's in the literature about how they're doing that.
Okay, well, help me thank John, everybody.
Great, thank you.